Hi, today we will learn about zero and negative integral exponents. Our objective is to apply the laws involving positive integral exponents to zero and negative integral exponents. First, let's have a review on the laws of exponents. If a and b are real numbers and m and n are positive integers, then a raised to m times a raised to n is equal to a raised to the sum of m and n. Say for example, we have x cubed times x squared. The product will be x raised to 3 plus 2. So we get x raised to the fifth power. Another law, we have quantity a raised to m raised to the power of n is equal to a raised to the product of m and n. Say for example, we have x raised to the fourth power quantity raised to the second power, that will be equal to x raised to the product of 4 and 2. So the product will be x raised to the eighth power. Another law, we have quantity ab raised to the power of m is equal to a raised to m times b raised to m. Say for example, we have x raised to the second power, y raised to the third power, quantity raised to the fourth power. That will be equal to x raised to the product of the exponents 2 and 4. So we have 8 times y raised to the product of 3 and 4, which is 12. So the answer will be x raised to the 8th power times y raised to the 12th power. Another law of exponent, we have quantity a over b raised to the power of m. It is equal to a raised to m over b raised to m, such that b is not equal to 0. Say for example, we have x over y raised to the third power. That will be equal to x cubed over y cubed. Another law of exponent, we have a raised to m over a raised to n. That will be equal to a raised to the difference of the exponents m and n. That is, if m is greater than n and a is not equal to 0. So say for example, we have x raised to the 10th power over x raised to the 3rd power. So this will be equal to x raised to the difference of the exponents 10 and 3. So we have x raised to the 7th power. Another law, we have a raised to m over a raised to n. That will be equal to 1 over a raised to the difference of m and n. In this case, that is if m is less than n. So say for example, we have x raised to the 3rd power over x raised to the 10th power. So if you will try to observe, the exponent in the numerator is less than the exponent in the denominator. So if this is the case, this will be equal to 1 over x raised to the difference between the two, 10 minus 3, and that will be 7. So our product will be, or the answer will be 1 over x raised to the 7th power. Let's have zero exponents. To simplify x cubed over x cubed, write the expression in factored form, and that is x times x times x over x times x times x, which is equal to 1 over 1, or simply 1. Since this is dividing powers with the same base, you can apply the rule in simplifying quotient of a power, which is x raised to m over x raised to n, and that will be x raised to m minus n. So applying the rule to the expression x cubed over x cubed, you have x raised to 3 minus 3, and that will be x raised to 0, which is equivalent to 1. So remember that any number except 0, when raised to the 0 power, it is always equal to 1. Let's have some examples. 2 raised to 0, this is equal to 1. Another, quantity x squared y to the 5th power raised to 0, that is also equal to 1. Another one, 4a squared b raised to 0. So this is equal to 4, the product of 4 times a squared times what is the value of b raised to 0, that is 1. So this is now equal to 4a squared. Negative exponents. Remember that for any real numbers a and n, where a is not equal to 0 and n is greater than 0, keep in mind that a raised to negative n is equal to 1 over a raised to n. And 1 over a raised to negative n is equal to a raised to n. Say for example, we have 3 raised to negative 2. So to get rid of the negative exponent, it becomes 1 over 3 squared, applying this principle. Simplifying this expression, we have 1 over, what is the value of 3 squared? That is equal to 9. Therefore, 3 raised to negative 2 is equal to 1/9. Let's have another example. 4 raised to negative 3. So to get rid of the negative exponent, applying this principle again, so we have 1 over 4 raised to the 3rd power. Simplifying, we have 1 over, what is the value of 4 cubed? 4 cubed means 4 times 4 times 4, and that is equal to 64. Therefore, 4 raised to negative 3 is equal to 1 over 64. Let's have example number 3. Quantity 1/2 raised to negative 2. So again, applying this principle, a raised to negative n is equal to 1 over a raised to n. So this expression now becomes 1 over quantity 1/2 raised to the 2nd power. Let us simplify. What is 1/2 squared? That is equal to 1/4. So we have now 1 over 1/4. It's like saying 1 divided by 1/4. And how do we divide fractions? In dividing fractions, remember that we multiply 1 by the reciprocal of 1/4, and the reciprocal of 1/4 is 4 over 1. So if we multiply 1 by 4 over 1, we get 4 over 1, or simply 4. So it means that 1/2 raised to negative 2 is equal to 4. Let's have the 4th example. 1 over 4 raised to negative 2. This time we apply this principle, which says 1 over a raised to negative n is equal to a raised to n. So this now becomes 4 raised to the 2nd power. Evaluating this expression, it becomes 16. So it means that 1 over 4 raised to negative 2 is equal to 16. Let's have more examples. Number 1, 5 raised to 0. This is equal to 1, because we have learned that any number except 0, when raised to 0, is always equal to 1. Number 2, we have x raised to 0 times y. So the value of x raised to 0 is 1. If we multiply it by y, so we get the product of y. Another example, quantity 3abc raised to the 0 power. This is equal to 1. Number 4, we have 4 raised to negative 3. So to get rid of the negative exponent, it becomes 1 over 4 raised to the third power. And this is equal to 4 cubed is equal to 64. Number 5, we have 1 over 4 raised to negative 3. This is now equal to 4 cubed. And 4 cubed is equal to 64. Let's try to answer this. Find the value of each. Okay, for number 1, we have 5 raised to 0 plus 5. 5 raised to 0 is equal to 1. If we add 5 to it, it becomes 6. So therefore, number 1 is equal to 6. Number 2, 14 raised to 0 over 3 raised to 0 minus 12. 14 raised to 0 is equal to 1. 3 raised to 0 is equal to 1 minus 12. So it becomes 1 minus 12, and that will give us negative 11. Number 3, 6 raised to negative 2. This becomes 1 over 6 squared. 1 over 6 squared is equal to 36. Therefore, 6 raised to negative 2 is equal to 1 over 36. Number 4, 5 raised to negative 2 minus 2 raised to negative 2. It becomes 1 over 5 squared minus 1 over 2 squared. Let us simplify. 1 over 5 squared is equal to 25 minus 1 over 2 squared is equal to 4. So we have 1 over 25 minus 1/4. Let's apply the butterfly method. 1 times 4 is equal to 4. Copy the sign, minus 1 times 25 is 25. And then multiply the denominators. 25 times 4 is equal to 100. So we have 4 minus 25. That will give us negative 21. Copy the denominator, 100. Therefore, it is equal to negative 21 over 100. Let's now proceed to number 5. 8 over 4 raised to negative 2. It now becomes 8 times, so we will put 4 raised to negative 2 in the numerator to make the exponent positive. So it becomes 8 times 4 raised to the power of 2. Simplify. 8 times 4 squared. What is 4 squared? 4 squared is equal to 16. So we have 8 times 16. 8 times 16 is equal to 128. Let's now proceed to number 6. We have 3x raised to 0 y. So this means 3 times the value of x raised to 0 is 1 times y. So we have 3y. Next, m raised to negative 5 over n. It becomes 1 over m raised to the 5th power n. Number 8, 4m cubed n raised to negative 5. To get rid of the negative exponent in n, which is negative 5, so we put it in the denominator. So it becomes 4m cubed over n to the 5th power. Number 9, we have p raised to negative 3 over q raised to negative 4. So in this case, we simply interchange. So q will be in the numerator to make the exponent positive. And then p will be in the denominator to make the exponent positive. So it becomes q raised to the 4th power over p raised to the 3rd power. For number 10, we have a squared b squared times a raised to negative 1, b raised to negative 1. First, we multiply a squared and a raised to negative 1. We add the exponents, so a raised to 2 plus negative 1. And then for b, we have b raised to the sum of the exponents also, 2 plus negative 1. So we have a raised to the first power, b raised to the first power. Simplify. If the exponent is 1, we no longer write 1. So it is simply AB. Write without zero or negative exponent. Number 1, we have 6. ABC raised to 0 over 2. This is now equal to 6 divided by 2 is 3. Bring down A and B. Since C raised to 0 is equal to 1, so this is equal to 3AB. Another example. Quantity negative 12x cubed y raised to the 6th power raised to 0 over xy raised to negative 5. This expression is raised to the 0 power, so it means that it is equal to 1. So we have 1 over x raised to 1 over xy raised to negative 5. To get rid of the negative exponent in the denominator, so we will put y in the numerator to make the exponent positive. So it becomes y raised to the 5th power over x. That is how we apply the laws involving positive integral exponents to zero and negative integral exponents. Thank you very much.